Piano tiles is a game where you have to score by clicking the black tiles. Clicking a white tile or skipping a black one will result in the end of the game. Here is a look at our gameplay. There are two modes in our game, fast and slow. I will begin with the slow mode. When I click on the black tiles, I score points. If I miss a black tile or if I click on a white tile, the game will end. This is our gameplay. Now we will see the implementation of the design patterns in our game. The first design pattern is the composite pattern implemented by Akshay Mhatre. In piano tiles, we see a hierarchical relationship between the row and the tiles. Each row has 4 tiles in it. In the gameplay, we see that the tiles keep moving in the downward direction. The downward direction, we can think of downward moving tiles as a single row moving down. Again, this calls for the composite pattern, where we can treat a tile and a row, which is a composition of tiles, uniformly. Let us look at the class diagram for this pattern. We have an interface named movable, which is the interface for the objects in the composition. The row class behaves as a composite which defines behavior for components having children. It stores leaves, which in our case are the tiles. The tile object are the primitive objects in the composition. The method move down in the interface is implemented by both leaf and the composite. The move down method is called by the client on the row class, which in turn calls the method on its children tile objects. The next pattern that we have implemented is the observer pattern.
Hi, this is Harish Umashankar. I'll be explaining the observer pattern that has been implemented in our game. As we can see, each time I click on the black tiles, the points are updated in the top right corner. We see that the points that are displayed in the top right corner are dependent on how the user scores. So we need to notify the points class that is responsible for displaying the score. Whenever there is a change in the score of the user, the behavior can be modeled using the observer pattern. Okay, let's see the class diagram of this pattern. The subject interface defines a method to add observers. In piano tiles, the score class is the concrete subject that implements the subject interface. The score class maintains the score of the player. The point class is responsible for showing the scores on the screen. The score class attaches the point class as an observer. Every time the score is updated, it notifies its observer. The score class calls the update method of the point class, and then points class fetches the latest score and displays it on the screen. Now let's see the strategy pattern implemented by Arjun Mantri.
Hello everyone, this is Arjun Mantri and I have implemented the strategy pattern. The game has two modes, fast and the slow. Depending on the player's selection of the mode, the game implements the strategy. As the name suggests, in the fast mode the tile moves down rapidly and it is difficult to score high points. The slow mode is comparatively easier and does not require much skills to master. Let us see how the two modes work. So firstly we'll open the game and select the slow mode and click on start, and as you can see the tiles are moving slowly and it is easy to score. So this is one pattern, one strategy. And now if we select the fast mode and click on the start, as you can see the tiles are moving fastly and rapidly and it is difficult to score the points. Now we'll look at the class diagram for the strategy patterns. The strategy interface is an interface that is implemented by all the algorithms. The game strategy interface in our game declares a calculate speed that is responsible for deciding the speed of execution. The context uses this interface and makes a call to the algorithm defined in the concrete implementation. The strategy context maintains a reference to a strategy object with it. It is initialized with the strategy at the runtime. In our game, the concrete implementation of strategy interface are the two classes slow and fast. They implement the common method calculate speed and define separate algorithm that decide the speed of execution of the game at the runtime. Thus, strategy pattern helps us to swap out algorithms easily to decide the behavior at runtime. If needed to add some other modes to the game, it is easy to extend just by creating another class that implements the game strategy interface. Now we'll look at the command pattern.
Hi, this is Dinesh. I'm going to explain the pattern, which is command pattern. Piano tiles has two modes in which it executes. The selection of the mode is decided by the user at runtime by clicking one of the two buttons, fast or slow. This selection by the user can be parameterized as objects. This behavior can be implemented using the command pattern. Command pattern has its advantages because there is no need for the client to explicitly know how the request must be handled. The client just instantiates the command and sets the receiver. The client then asks the invoker to execute the command and the command carries out the request. The receiver has the knowledge of processing the request. We will see how the piano tiles implements the command pattern. So here is the command pattern class diagram. The concrete command defines a binding between the receiver and the action. It implements the execute method by invoking the corresponding operation on the receiver. The button fast and button slow implement the invoker interface and have the reference to the commands. They are responsible for asking the commands to carry out the request. The concrete command has the execute method which invokes the operation on receiver. The receiver implementations decide what command is processed. This pattern makes it easy to add other commands by decoupling the invoker from the objects that handles the invocation. We will see the command pattern that implements the selection of game mode in our game. Now Akshay is going to explain the singleton pattern which we have implemented.
So the next pattern that we have implemented is a singleton pattern. In piano tiles, we maintain the score at one single place. When any object in the game wants to have access to the current score, one consistent value should be served. By making the score class singleton, we can serve this purpose. In score class, we have a static getInstance method which makes it sure that only one instance is returned whenever requested. The private constructor prohibits any other class to create the instance of score class elsewhere. Let us see all of these patterns in action at once. So these are game piano tiles. We have two modes, slow and fast, decided by the command pattern. When we select the slow, the strategy for the game is decided by the strategy pattern. The points are updated in the top right corner, which is decided by the observer pattern, and the rows that are moving down are decided by the composite pattern. So this is our representation of the CMPE 202 project. Thank you for watching.